to predict movie success, specifically an IMDb score given a movie's specific attributes using regression, classification, and clustering models. So first, I'll just give some background on what I did on my midterm. We'll just read the data and load it and take a look at some of the columns that we've got just to get a preliminary view of our data. And then I'm going to skip to what I found to be most relevant for this portion of the project. After some visualization and data analysis, I finally came to correlation analysis. And here this kind of shows the correlation between our variables and our IMDb score. These helped me or guided my project and helped me find the variables that I wanted to use for some of my models. So off of this, we see some strong positive correlations between IMDb score and number of critic reviews. So the higher number of critic reviews, the higher the IMDb score. Duration, the longer the film, the more it will receive a high IMDb score. Number of voted users, number of user reviews, Facebook likes, and gross earnings. So now I'm going to talk about my model building. So now that we have information on our significant variables, we can use those variables to become the base of our model building. For these purposes, I will use duration, number of voted users, and number of critics for reviews to develop 3 regression models. So I'll start with a single variable regression. I built 3 models and I decided to show and talk about the best model that I developed using regression. My second model used number of voted users as the X variable and, of course, IMDb score as the Y variable. This is what it looked like when we evaluated the performance of the model's prediction using visualization. Doesn't look super good, but it was better than my other 2 models with a mean square error of 0.8465. And then this is just another visualizer of that same one. We can see that R square is 0.233. Not as good as you would normally like to be. Still is greater than 0. So then I used regression using stats models, and we see here that there might be an indication of strong multicollinearity or some other problems. Our R squared is 2.233. So if we go back, it's the same. And then looking at plots, this is plotted of the number of voted users for the model that I found to be best for regression. And this is a visualization of a fit plot with number of voted users and IMDb score. So then I did multiple regression. Using a multiple variable regression, I wanted to look at what I believed from previous analysis were the most influential factors. So I assigned columns to X and Y. I used duration, number of voted users, and number of critics for reviews as my X variables. So this is just showing creating my data set and my training and test sets. And the mean square error for this one is 0.7485. And our goal is to reduce the SSE and higher the R square. So this one isn't as good. Let me look at this. Our R square 2.86. So then I chose two variables to develop a multiple linear regression model using number of voted users and number of critic for reviews. And this had a little bit better R square, but not by very much at 0.24. As we can see here, these high values indicate multicollinearity. So we can fix that by doing some lasso regression. We fit the model, and our mean square is 0.83, and our R square is 0.24. Classification. I wanted to start by looking at the types of values we have for variables. In classification, we don't want to use any objects or categorical variables, so I use this to exclude the objects, and now we have numerical. So then I made some bins for the IMDb scores to evaluate whether they were a poor, okay, good, or excellent movie. I had some troubles with binning the poor, which resulted in some lower accuracies with my models, but that is something that can be fixed and changed and made better in the future. Just to visualize this really quick, looking at the IMDb score and the IMDb label, this is what it's labeled. So you see that a 7.9 is labeled as good because our good is 6 to 8, and here we see the 8.5 is rated as excellent, as 8 to 10 is excellent. Decision tree building, validation, and evaluation. So this is my accuracy for my decision tree. 0.66, not too bad. We see a lot of good movies being accurately classified, but not so much on the poor side, I'm guessing because of my bin issue. And this is just a visualization of that. As you can see here, 548 good movies were classified as good movies. 161 okay movies were classified as okay movies. 25 excellent movies were classified as excellent. But we see some large misclassifications here, with okay movies being classified as good movies and okay movies being classified as good movies, or good movies being classified as okay movies. And then, as we can see here, this one is a larger decision tree, so it is not easy to read. So I will make a simpler decision tree here, and then accuracy is a little bit better, 70%. We see even more, 639 with the good, and a little bit better precision in the excellent movies. Still, we see poor precision, 0, thus bringing down the overall accuracy. Here we can see my new simpler model, number of voted users as seen as the most important factor, And then going from there, we see duration and budget. And it's much easier to read than the first. KNN. My KNN model was pretty low, probably the worst model that I deployed, 0.59 accuracy. We have a lot more movies in this case that are classified themselves, but a lot more misclassifications than correct classifications. And then we evaluate the model using a tenfold cross-validation here. Our best model had the N neighbors set at 24. Logistic regression had a 70% accuracy. You see it gets pretty high in the excellent and tons of classifications for good, correct classifications. Still a problem with the poor. Random forest classifier, better, probably my best model, 78%. We see very, very many excellent and good models being correctly classified, and that poor value kind of drops the accuracy. Clustering. So first we want to check the variance before normalizing, and I again took out any categorical variables as well as category variables, normalize the data, and redo the variance, and now we can see it's all equally distributed. So we set our index, and we just kind of want to look at this and our clusters. We can see in a cluster 1 we have high critic reviews, a little bit longer durations it looks like, and big gross numbers and lots of number voted users. The means of our clusters, we can see for cluster 1, a better movie. There are a higher number of critic for reviews, higher duration, more Facebook likes in general, and more number of users for review, and a higher IMDb score as a result. So in this, there are more observations in 0 than in 1. There are more classifications of less than excellent, and so that's what I believe to be the main factor. And we can look at this again. And then we build a decision model from here. Check the accuracy, actually pretty good. And here from this, it lists the importance. And we can see that number critic for reviews is most important, number voted users being second, and number of users for reviews being third. Clustering analysis using agglomerative clustering. We can view our dendrogram and a second one here. Working. So for my story part, throughout the analysis, I gave some insight as to what key factors might translate into a high IMDb score. Though I found the beginning of this analysis through just basic statistics and correlations, I found that once I got into model building, the significant factors were number of critics for review, number of voted users, and Facebook likes. There were some discrepancies with my models because of the bins that I created, especially for the bin of poor. And that is something that if I repeated this, I would like to go back and better create.